Mark Donnigan is going to be leading our session, our first session of the day. He's the Vice President of Marketing for Beamr, and he is going to be giving a presentation called How to Apply Content Adaptive Encoding to Reduce Bit Rates up to 50% without any loss in quality. That sounds fantastic. Mark, take it away.
Okay, good. Thank you for attending. So with that, let's just jump right in. So I'm going to tell you about Beamr. We're going to talk about our technology, but as Troy said, the intent is for this to be actionable and practical. So the topic is content adaptive and content adaptive encoding techniques, specifically what methods are possible. And this, of course, plays right into the strengths of who our company is. So for those of you who don't know Beamr, or as a quick refresh, we were founded in 2009. And what's unique about us is that we were founded expressly to develop content adaptive technology. To date, we have 29 patents in the area that have been granted. We have 18 pending, and we're filing, for new IP almost every quarter. So this is what our company focuses on. Our first commercial implementation of a content adaptive solution was a product, actually it still is a product, called Beamr Video. It's been renamed Beamr Optimizer, but we actually introduced that product in 2013 at IBC, and we've been shipping that since 2014. So this is all just to give some, some validation, help you see that, we actually do know what we're talking about in this area. It is what our company focuses on. And in 2016, we actually acquired an encoder company, a company called Vanguard Video. Some of you may recognize the name, may know the company, some may not. Vanguard actually has been involved in the area of codec development, software encoder development for many, many years, more than 15 years, is under the hood of most of the commercial products that you probably use. So our customers, you can go on our website and see, you'll see Netflix logo, you'll see Microsoft, you'll see many other major brands that are using our solutions. So let's start with what is content adaptive encoding. And, there's probably different definitions floating around, but just so that, we level set and we're kind of using the same terminology throughout this presentation anyway. Really, it's as simple as using the right bit rate based on the needs of the video. And that sounds sort of like, well, of course, that's obvious. But we're going to talk about how even within this definition that there's incomplete solutions that are out there. So, obviously animation has a very different need in terms of how that encoder is set up and what the encoder is doing than, maybe high motion in action movies, sports, etc. And so the concept is that what we want to do, the holy grail for encoding, is obviously to only use the exact number of bits that are required to properly represent the video at the quality level that we're targeting. Many of us are probably using adaptive bitrate strategies. And, the question could be asked, well, is ABR, adaptive bitrate, is that content adaptive? And the short answer is no, it's not. Because ABR is designed to address the needs of a varying network. So when my bandwidth is fluctuating, then I'm changing profiles, I'm changing bit rates, right? It has nothing to do with content quality. And so when we look at the needs of a content adaptive encoding scheme or schema, if you will, we can think about there's kind of four main approaches that we can consider. And so I want to take a few minutes before we talk more specifically about what Beamr's approach is and what our technology does. But the first is, I'm venture to say this is streaming media, so there probably aren't too many Blu-ray compressionists in the room. But if any of you have spent some time, in the Blu-ray space, then you know that you can apply a manual process. You can get a very, very good result, very high quality, often at very low bit rates, because you take the time. right? And so manual optimization is kind of the brute force, the simplest way of saying, hey, if I have the knowledge, if I know how to use my tools, I can get a very, very good result, but it's very time intensive and, it's not practical for high volume workflows. Some of us might be using a category approach. So we've gone through our library and we're segmenting based on drama, based on animation. We might even be getting more granular 2D, 3D animation. Maybe you're going so far as to develop a recipe for hand-drawn animation. So that's an approach that I'll talk in just a couple minutes about some of the pros and the cons of that and what you need to consider. And then there's the Netflix approach, and that's by title. And this actually, as we'll see, is probably outside of what we're doing the most effective approach. But it's got some major pros and it has some cons as well. It helps if you have 5,000 EC2 instances that you can rely on. It helps if you don't care how long it takes. So there's some major benefits. There's some drawbacks to it. And then there's the frame-based approach, which I'll explain here in a couple minutes. So let's start just real quick. I'll kind of breeze through this first one because it's sort of obvious that why it's not real practical for most of us, at least involved in streaming media production, streaming media encoding. So manual is just as it implies, right? You are manually setting up the encoder, going GOP by GOP, maybe even literally certainly scene by scene, but going down the GOP level, maybe even individual frames. Our technology is actually used in Hollywood. We have major studio Warner Brothers that is shipping Blu-ray titles using our solution. And so we've been in those rooms. We know what it's like when literally a compressionist is spending tens of minutes, if not even hours, on a 10-second scene. It's pretty amazing to watch them in action. It doesn't work in our environments, right? The pro is you get very high quality. The con is that it's time consuming. It's certainly not scalable. The next approach, the category level. Now, Jan Ozer, if any of you have read his book on Video Encoding by the Numbers, if you haven't, it's definitely worth reading, so get a copy of that. Jan actually does a really good breakdown of how this works. So if you're not familiar with kind of the mechanics of how to implement this, I recommend getting the book. Basically, it's really not much more complicated than looking across your library and segmenting based on sort of groupings of content type. So again, as I said, animation, drama, action, sports, how granular you get in that sort of depends on, how much resource you have and, how advanced you want to design your encoding profiles. But the idea is that you select 3 to 5, maybe even a dozen, it's up to you, representative videos. You manually encode them, multiple recipes, multiple bit rates, and you come up with kind of a representative recipe, if you will. And then you simply apply that recipe to every video that's in that category, right? So this obviously does give you some benefit because it's very clear that the needs of an action movie where, in certain scenes, literally every pixel may be in motion, the needs of that type of video is very different than a drama or, kind of a slower moving. So that's definitely a pro. The con is that this approach doesn't take into account, complexity inside the video. So even though it may be that there's kind of a drama movie that 80-90% of the movie is very slow motion, it's not very complex video, maybe there actually are some scenes that have a heavy CGI, that have, maybe there is a lot of motion. And if you want to preserve that, then this approach may not work. We were involved in one project where a particular encoding approach did an excellent job across the entire motion, the feature film. The problem was the studio logo was especially problematic. And so they were having to make trade-offs in the encoding profile just based on preserving the studio logo. Sounds crazy, but when you're a studio and you're preserving a logo, that's your brand, right? So one of the challenges with this category level is that it may work across 70, 80, 90% of the video, but maybe the 10% that's compromised, or even the 2% is the 2% that the producer, the DP, whoever says that's a no-go. You got to fix it. The other thing is that this requires manual QC. So you definitely get into, some QC process. Now, the title level is actually very interesting, and I'm going to assume that many of us have read or studied or heard Netflix even directly talk about what they're doing. If you have not, this was initially published on their tech blog December 14th. 2015. And so you can go read, and there's been a lot of other subsequent, blog posts by them and others that talk about what they're doing. But what we're looking at here is basically, if you have the benefit of a quality measure that can reasonably approximate human vision or the human visual system, and is reasonably accurate across a wide library of content, then you can apply this and perform a dozen, 20, maybe 30, or even 40 encodes of a particular title. And what you're looking for, and what this graphic illustrates, is the convex Hall, which is to say that if I chart quality versus bitrate, we all know that there's kind of a knee where if I encode at a higher bit rate, my benefit is very minimal. In fact, there's even a point where I can increase a bit rate so high that my quality begins to decrease, and that's an interesting artifact of certain encoders. But the holy grail, again, would be if I can find for every title, for every video piece of content, every asset, if I can find precisely where that knee is, where if I encode any more, my benefit really drops. I'm using more bits, I'm really not getting that much better quality. Or if I drop significantly lower in bit rate, then my quality really starts to fall. So what I'm looking for is kind of that knee. And all Netflix did, or is doing, is basically they look at resolution, so 720p, 1080p, and 4K, and I'm sure they're probably applying this all the way down, into 360p perhaps, 480p. But simply mapping these, and when you do this across a somewhat limited library, which it may sound like 100,000 assets or even 500,000 assets is not a limited library. For some of us, that's a massive library. For some of us in the room, that's a very small library. So if you're on the user-generated content side, you're thinking 100,000 assets, I ingest that, every couple, 3, 4 days, maybe even every day, depending on who you work for. But if you're a VOD service, your total library size is what, 100,000 assets, maybe. Maybe you've got 500,000 because you have TV episodes in there. So it doesn't become too crazy to think about that you could run this exercise across a pretty significant portion of your library. But then again, do you have 5,000 Amazon EC2 instances sitting there waiting? Do you, are you able to, encode in, run your encoders in very, very slow mode? And so not all of us can do that, right? So this approach is probably outside of Beamr the closest to any real solution that is a commercial deployment of content adaptive. And it certainly improves significantly beyond TN2224. And as much as Apple updated their HLS guidelines, I believe about 18 months ago, still, if we look at our profiles, probably most of us are pretty much basing our profiles off TN2224. So there's some definite pros there. Now the cons is that this approach still does not take into account complexity between scenes. In fact, Netflix actually addressed this. So they talked about this last year in an IEEE imaging conference that they participated in. Again, you can go read all this. So this is all public domain stuff. So And also it's very high computational complexity, extremely high. Just the quality measure itself. And I'm speaking of VMAF. Again, VMAF is open source, so if you played around with it, then you already know that. If you're thinking, hey, maybe that's an approach that I can adopt, very, very computationally intensive. Some of our workflows, that's perfectly fine. Many of our workflows, it's not. It would be nice if it was, but it's not. We don't have unlimited resources in the cloud, and we do have to be concerned about compute cost and complexity. So let's look at an alternative. And the alternative is to perform this function, this content adaptive function at the frame level. And this is the heart of what Beamr has developed. So I'm not talking about products today. This is technology, and I'm actually staying very, very narrow in the implementation of content adaptive. And there's kind of four main pillars, if you will, to what we have built. The first is that it's high reliability, extremely high correlation with the human visual system. And this is, if you have any experience with PSNR, SSIM, or any other quality measures that have been developed, commercial or academic or otherwise, they all tend to fall down at some point. Ours has been proven to have extremely high correlation. As I mentioned, we're in use from Blu-ray all the way to user-generated content. So high reliability is very, very important, and we've designed for that. Codec suitability. Now, what we mean by this is that everything we do is in the standard of block-based encoding, specifically H.264 and HEVC. So there is absolutely nothing that we're talking about or nothing that you're seeing or that you're hearing me reference that is, well, it's really cool, but there's a proprietary element to it. That's why everything can work fully inside, whether it's to a set-top box over a QAM network, whether it's a Blu-ray standard on a Blu-ray player, whether it's streaming to a standard connected device. As long as it's H.264, HEVC, it has full codec suitability. It's image adaptable. And this is very important because if we're going to talk about removing bits, which is what we're talking about, we need to know where is the eye most perceptive. And so the last thing we want to do is just, quote, kill all the high frequency because, quote unquote, that's in the background, right? And yet reality is maybe that's in a portion of the frame that actually would be very visible. So we spent a lot of time working on it. A lot of our patents are in this area of call it image adaptability. And then it has to be low complexity. I already stated that one of the drawbacks to the per title approach, similar to what Netflix is doing and others, is that it's high complexity. So it doesn't work in real time. Ours works in real time. In fact, at NAB, we demonstrated that. And if you stop by our booth, we're in 120. You can see examples of that. So very high reliability, works with standard codecs, perfectly mapped to what the human perceives as quality, meaning the eye, and then low complexity, so it works in real time. So let's go kind of one step lower into a block diagram. This wouldn't be a complete presentation if I didn't have a block diagram, system diagram. So here we go. Basically, this just illustrates where we fit into the encoding process. So the video encoder. Now, we did acquire, we own Vanguard Video, so we are absolutely in the encoding business. We're a codec developer. We have a very strong team in Russia just focused on HEVC and H.264. But at the end of the day, we didn't develop we haven't come to market with a new codec. Okay, because we believe very much in standards, and we have planted our flag very firmly in HEVC. just as an example, although we also are very strong in H.264. But the point is, the video encoder is the video encoder. Okay, so again, there's not something proprietary there that then, if you want to implement, you've got to make changes on your player, or you have to do something special to get it to play. The output streams that we output work on across any device that can decode H.264 or HEVC. The system controller and the quality measure analyzer, that's where our IP is. And the system controller basically is, as sort of the name implies, and obviously the description is simple, the implementation is complex, but this controls the iterative process of how we're doing our frame level recompression. And that is what's happening. This is an iterative process, and that's very, very unique. And then the quality measure analyzer is, of course, what is correlated to human vision. And I'm getting the flag on overage, so I think I will just skip ahead here. And let's see here. All right, let me just show you this slide, and then I'll wrap up with a summary. And then I just encourage you to stop by our booth. 20 minutes is not enough time. So, okay. What you're looking at here is, this is a very interesting graph. This is VBR. This is our HEVC encoder. This is a very well-established encoder, been shipping 3 years in the market, used by the largest HEVC distributors in the world. What this is showing on the VBR graph is basically the actual bit rate versus the target bit rate, and it's completely linear, as you would expect it to be. Our new mode, CABR, which is our content adaptive, you'll notice that we have a 50% savings between the VBR mode and CABR. And again, we can explain a lot more. Come see us, in the exhibit hall, and we'll go into, much greater detail as to what this exactly means. But there's a couple important takeaways. First of all, I'm not comparing to another encoder. So this is not a shootout Beamr versus X265 or encoder Y. This is literally against our VBR. So we're comparing our output, VBR, compared to our new CABR. And we also have video samples that you can actually look and you can see. For the first time, 1080p HEVC is possible at 1.5 megabits. And with quality that is absolutely considered, state of the art on a mobile phone, and on a TV, maybe you want to go up to 2 megabits, but that's unheard of right now anyway. Okay, quick summary. Fixed ABR, adapts to network conditions, not content. So content adaptive encoding obviously ensures optimized bit rate and quality. Manual methods aren't scalable. Per title methods, just too CPU intensive for most of us. Not everybody, but for most of us. Frame level content adaptive encoding is, really offers the only real solution for best bit rate and quality trade-off. And we are the first to actually have implemented a commercial content adaptive solution, and that's in the product Beamr 5X and also in our Beamr optimizer. So come see us at booth 120. Thank you so much for coming. Now, I know, Troy, you were mentioning we have a giveaway, so I haven't forgotten. Yes, so we do have a giveaway. So if you are doing encoding for a content distributor, or if you work for a media and entertainment company, in other words, you're a content owner, then we would like to offer you a free evaluation license that is really fully featured. Like, this is the full product. So come see me, give me your business card, either after or at the booth, and we'll make all the arrangements to do that. So we appreciate you coming and listening to our presentation, and we want to give you something back in return.